This is Mark Summers from Summers Technical Services with another SolidWorks tutorial today. We're going to make a CAD model of a DIN rail, looks similar to this, and I've got a data sheet we can look at that has the dimensions of our DIN rail we want to make. So to get started with, I select my new button. I want a millimeter part, so I select my part template. It's got millimeter units is already set up. First thing we're going to do is sketch our extrusion cross section on the front plane. So I select that front plane, go to sketch, and now I can start sketching. First thing I want to do is add a center line going through vertical center line through my part, because I want to take advantage of symmetry in my part. So I want to select that center line and go back to the options and make it infinite length, so I can remember it's not part of my geometry. Now I want to go back to the regular line sketch, line tool, and start sketching my cross section. When I do that, I want to again take advantage of these geometric constraints that automatically get added if I carefully select them. So here when I get near horizontal, I get that horizontal indication. So I click then, so I get those constraints added as I sketch my cross-sectional shape. You also notice I get indications here where I'm lining up with other geometry that I've already sketched. That lines it up on the screen, but it doesn't add any constraints. Now when I get through closing, this last one I purposely didn't put vertical, so it does not have these constraints on there. But if I select that line and make him vertical, that'll add that relationship. Now all my lines are vertical or horizontal, and now I'm going to get ready. I'm ready to start adding relationships to take advantage of the symmetry. So to do that, I'm going to right click on the screen here and add relationships. First thing I'm going to do is put my center line right on this origin. So I'm going to select the origin, select my center line, and make them coincident. Right click, clear those selections. I'm going to do a similar thing with the origin and its bottom line. I want to make it on the midpoint so it's centered left to right, and also make it coincident. So now that bottom line is totally constrained because I've told it to be a midpoint and also told it to be coincident with the origin. Now I'm ready to add some symmetry relationships. So again, I right click, add relationship. And now I'm going to be selecting my center line, two vertices, and then select symmetric. Right click, clear those selections. Do it again for these two inside points here. Make those symmetric. Right click, clear selections, and add one more for these two bottom corner points. Symmetric. So these are adding indications on the screen as well as the geometric constraints to the sketch. Now as I move these corner vertices around, I'm starting to see that, yeah, my constraint is getting geometrically constrained. I've still got one problem here. These lines ought to be collinear. So this is a good way to find missing constraints, is by dragging those corners around. So if I right click, add relationship, I'll add one more geometric constraint between that line, and one of the options is collinear. So now I think I'm ready to start adding dimensions. I just use my smart dimension button, because it's going to guess what kind of dimension I want based on the entities I select. So this one we're going to make 35 millimeters as indicated by the data sheet. This dimension here, if I remember correctly, is 27 millimeters, and the overall height is 7.5 millimeters. Now my last dimensions are going to be for this thickness. I'll select that one, make that 1 millimeter, and do the same for these other legs. You'll notice this other vertical web over here also goes to 1 millimeter, not because of a dimension, but because of those previous geometric constraints. So the last dimension I think I need here is this other 1 millimeter. Now I'm totally black on all the sketches, so I'm ready to approve the sketch. I'll exit sketch. With it selected, I'll go to the feature tab, extrude, add my length of, I'll make it 200 millimeters here to start with. And I think I'm going to, instead of blindly extruding one direction, I'm going to choose the midplane. So I get even distances, both directions. That way my front plane is right in the center of the part. You've noticed I didn't put these fillets in there. There's corner fillets of 0.8 millimeters that I left out. I left those out on purpose because I want to keep my sketch simple and add these fillets later, which is much easier. So I'll go to the fillet command. When it pops up, I'll type in the 0.8 radius. It's going to be for the inside. It's asking for the items to fillet. I add these 1, 2, 3, 4 edges. Approve that. Now invoke the command one more time. This time I'm going to have the outside bends. So to keep the part even thickness, I'm going to type in 1 plus 0.8, part thickness plus the inside bend. It'll make that calculation for me automatically. And now I want to select these outside corners. And approve the feature. So now I have my shape correctly created. Now I'm ready to make my slot. I'll go in back to the sketch tab, select that face, sketch. And I could make a couple of circles and lines and do tangents and things, but Solidworks has got a nice feature here. I can make a straight slot, select the location for the vertical long length of the slot. Once I do that, it's going to draw me my slot for free. That's pretty neat. Now I can add the dimensions. It's already got geometric constraints built in to keep it a slot. So I'm going to grab these two outer edges, put in a smart dimension of 6.2 millimeters. And then the length of the slot is 15 millimeters. So that tells me that from here to here is going to be 15 minus 6.2. I'll type it in as the equation. It'll calculate it for me correctly. Now I need 2 more dimensions to locate the slot to the rest of the den rail. So I'll dimension from the center of the slot to this edge here. That's going to be half a slot pitch, which is 25 divided by 2. And now I need to locate this side to side, and I'm going to take advantage of another geometric constraint. So I'll right click, go to add relationships, and I want to locate this origin point to the center of that slot. So I'm going to select that line there, and I want to give me a top view and select the origin and tell those to be coincident. Now if I've done that correctly, my slot will be, my sketch will be all black. That's good. Get out of the sketch. Sketch is selected. Go to the features. This time I'm going to do an extruded cut. I could make it 1 millimeter thick, but the design intent is that it goes all the way through the part. So instead of blind, I'm going to say through all and approve that for my slot. Now that I got my slot, I can do the pattern. Finish the part up. I select the feature, go to linear pattern. It's going to ask me for a direction, and I choose an edge for the direction. I'll choose that edge right there, it's convenient. Type in the pitch, which is 25. And now for the number of slots, it's not clear to me what that is, so I made me a little AutoCAD sketch. Here it is here, 200 millimeters. I've got 25 millimeter pitch. So 1, 2, 3, 4, 5, 6, 7, 8. 8 slots, 25 pitch gives me a 200 millimeter long den rail. So I type in 8. That looks correct. I'll prove that. There we go. Now I've created my part. Now we can stop here and have a good model of our den rail, But in the future, I might want to have different lengths of DIN rails, and I'd like to be able to have them automatically update based on the length I want to make them. So if I come up with a design rule that says the lengths have to be in multiples of 25 millimeters so that the slot where I cut the DIN rail is always centered between two slots, I can do something using equations. So what I'm going to do is go to Tools, Equations, and I'm going to create two things. I'm going to create a global variable, and I'm going to call it L, and it's going to be equal to 200 millimeters. I'm going to say OK. Now my model has not changed because I've defined that global parameter as L, but I haven't used it in my sketch yet, or features. So on this first feature, I'm going to edit this first feature, and where I have 200 millimeters, I'm going to change that to that global parameter. So I'm going to get rid of 200 and put an equal sign, pop down to global variables, and type in L. So this is going to be equal to L regardless of the other features. So now if I go back to Tools, Equations, change my global variable to say 2000, which is the length of the DIN rail I purchased, it updates that because I've tied that to the length. However, you'll see my slots have not updated. So it seems to be I need to have another parameter for those slots, but really, based on my sketch over here, regardless of the length, the number of slots is going to be the length divided by 25 millimeters. So I want to add that to my equations so that it updates not only the length, but the number of slots each time that I update that one parameter. Again, we're going from a good model to a great model. So now I'm going to go inside my pattern, edit that feature, and when the dialog box pops up, I want to get rid of 8 and type in equals global variables L divided by 25. So regardless of what L is, it always makes this calculation and updates those parameters, updates those features. So now I've got a great model. I've got the length and the number of slots tied to one variable. So if I go back into Tools, Equations, and change L from 2000 to 200, not only does the length update, but also the number of slots update. And that's what I want. I want to have a great model. Now this model can be used for multiple instances and assemblies, and all I have to do is change that one parameter to whatever length I need, and the model will update accordingly. So that concludes the tutorial on making our assignment 2 DIN rail. Look for more tutorials like this at Summers Technical Services, www.marksummers.net.